This lesson covers multiplication of matrices. To multiply two matrices, the number of columns in the first matrix must equal the number of rows in the second matrix. For example, if our first matrix is of size m by n, the second matrix must be of size n by something, we'll call it p, and this would result in an m by p matrix, a matrix of size m by p. Let's find A times B and B times A for the following two matrices. A is equal to 3, negative 2, 4, 1. B equals negative 1, negative 1, 0, 4. And note that A is of size 2 by 2. B is of size 2 by 2. The number of columns in A is equal to the number of rows in B, so we can find AB, which we will do one step at a time. Starting with, I look at row 1 in A. I will multiply it times column 1 in B, which gives me 3 times negative 1 plus negative 2 times 0. This goes into row 1, column 1 in our new matrix AB. Then we'll take row 1 in A times column 2 in B, giving us 3 times negative 1 plus negative 2 times 4 in row 1, column 2 in matrix AB. Then we look at the second row in A, the first column in B. We take 4 times negative 1 plus 1 times 0. This goes into row 2, column 1 in our new matrix AB. And we move on to row 2 in A times column 2 in B. We have 4 times negative 1 plus 1 times 4 in row 2, column 2 in matrix AB. Simplifying gives us a matrix AB of negative 3, negative 11, negative 4, 0. Next, let's find B times A. This time we won't go through all the steps, so those might guarantee more of a correct solution, but let's see if we can do this in our heads pretty much. So B times A, I want row 1 in B times column 1 in A, negative 1 times 3 plus negative 1 times 4 is equal to negative 7. Row 1 in B times column 2 in A would be negative 1 times negative 2 plus negative 1 times 1, giving us 1 in matrix BA. Moving down to row 2 in matrix B, 0 times 3 plus 4 times 4 is equal to 16. And then row 2 in B times column 2 in A, 0 times negative 2 plus 4 times 1 is equal to 4. Okay, so matrix BA is negative 7, 1, 16, 4. Note that matrix AB, which was negative 3, negative 11, negative 4, 0, is not equal to matrix BA. In fact, matrix multiplication is not commutative. Usually, matrix AB will not be equal to matrix BA. The identity matrix is a square matrix with ones down the main diagonal and zeros elsewhere. An identity matrix can be of any size as long as it's square. And we'll look at an example using the identity matrix. If we take the matrix A here times the identity matrix, let's see what size of identity matrix we'll need. Well, A is a 3 by 2 matrix, so we'll need to multiply that times a matrix 2 by something, and since the identity matrix is square, it will need to be a 2 by 2 matrix. So let's take matrix A times the 2 by 2 identity matrix. We take row 1 times column 1, negative 1 times 1 plus 3 times 0 gives us negative 1. Negative 1 times 0 plus 3 times 1 gives us 3. We move on to row 2 in A. 2 times 1 plus 1 times 0 is equal to 2. 2 times 0 plus 1 times 1 equals 1. Moving on to row 3 in A. 3 times 1 plus negative 2 times 0 equals 3. And 3 times 0 plus negative 2 times 1 equals negative 2. We have the matrix A times I. Note that the matrix A times I is equal to the matrix A. This will always be the case. It will also be the case that the identity matrix times any matrix A is equal to that matrix A. And we can think of the identity matrix as being the multiplicative identity for matrices, just as the number 1 is the multiplicative identity for real numbers. Try on your own. Find matrix AB using the following two matrices. A equals the 2 by 2 matrix with 2, -2 in the first row, 0, -3 in the second row. B equals the 2 by 3 matrix with 1, -5, 6 in the first row, 4, -2, -3 in the second row.